Hi everyone. Today we're going to be talking about how to add and subtract linear expressions. We had looked at last chapter um, some of these linear expressions and combining like terms and some of those ideas of what are like terms, what are terms. Now in this section we're going to look at actually being able to combine a couple expressions or add and subtract expressions. For our learning target today, we have I can explain how to add and subtract linear expressions. And I'll go over a couple different methods with you today. First, we want to describe though, um, or figure out what the heck a linear expression is. So a linear expression is an algebraic expression. So again, when I hear algebraic expression, I'm thinking of like a math sentence in which the exponent of the variable is 1. So in this case, these are examples on the top row here of linear expressions. Negative 4x. I have a number and a variable. It's saying to multiply the two, and notice how my variable, the exponent of the variable is 1. There's no exponent up here. And you'll see that's the same with every other one of these expressions. There is no exponent, right? There's no exponent above my x here. If you look at the nonlinear expressions, you'll see you have an exponent of the variable. So x squared, x to the third power, x to the fifth power. These are examples of nonlinear, meaning that if you are to graph them, they would not make a line. These expressions, if you were to graph them, would make a line. They're linear. Okay. So it says you can use the vertical or horizontal method to add linear expressions. So you can use the vertical or the horizontal. And all that's saying, and I'll give you an example of that, is like when you're adding, say you have 10 plus 5. Well, you guys know mental math, that gives you 15. This would be a horizontal way of thinking about this, right? You could also use a vertical method. You could say 10 plus 5, and you could line them up vertically like this, which would give you 15 as well. So we have a horizontal and a vertical method for adding. We have the same idea for subtracting. We have the same exact idea for expressions. So for letter A, it says find each sum, x minus 2 plus 3x plus 8. So first I'm going to show you the vertical method. X minus 2, and I'm going to add to that 3x plus 8. Notice how I lined them up like that. Okay. Next, I just add like I normally would with the vertical addition. So I have negative 2 plus 8. That would give me, let's see, positive 6. And x plus 3 is, x plus 3x would be 4x. So I would end up at 4x plus 6. Now, the other way that you can do that is to use the horizontal method, where you just look for like terms. So for example, you see you have an x and you are adding to that 3x. Well, x plus 3x would be 4x. And you also have another set of like terms that's negative, let me change my color, negative 2 plus positive 8. So negative 2 plus positive 8 would be positive 6. And notice that we got the same answer here. When you're doing the horizontal method, you really just need to think, what are my like terms and how can I combine them? Okay, so there's just an example of each one of those methods for adding linear expressions. I'll just pick one here for letter B. It says negative 4y plus 3 plus 11y minus 5. I'll just do the horizontal method. So I'm going to look for like terms. I have negative 4y plus 11y. Well, negative 4 plus 11 would give me 7y. And then my other like terms, I have positive 3 plus negative 5. 3 plus negative 5 would be negative 2. Same thing as subtracting 2. So 7y minus 2 would be the answer for that linear expression. Let's spice life up a little bit and get a little more complicated. In this example here, I've got 2 times negative 7.5z plus 3 in parentheses. So I'm going to need to multiply everything in my parentheses by 2, or double it.
Excuse the interruption.
Sorry
Just
for the
a
interruption.
reminder of the COVID vaccine clinic. If you have the forms in your backpack or with you, please bring them to the office at this time.
All right, thanks for the break, guys. Sorry for that interruption. Let's double what's ever inside the parentheses here. 2 times negative 7.5 would be negative 15z. I'm just doubling this. Plus 2 times 3 is 6. And now I need to add the rest of that. So I'm going to use the vertical method here. So I'm going to add 5z minus 2. Okay. When I do that, negative 15z plus 5z would be negative 10z. And 6 plus negative 2 would be 4. So plus 4. Negative 10z plus 4. And the only difference from what I had to do in example 1 is first I needed to distribute my 2 to everything inside the parentheses. In other words, double what's ever inside my parentheses because there's a 2 on the outside of it. All right, got a few Oyos for you to try out here. Please pause the video now to try 1 through 4. All right, for time's sake, I'm going to give you the answers, but please come ask me if you need help figuring any of these out. X and 2x is 3x. 3 and negative 1 is 2, so 3x plus 2. This one, negative 8z plus 8z, well, that cancels out. Those are going to be 0. And then I have 4 plus negative 7, which is just negative 3 for your answer for number 2. Number 3, you need to distribute first the 2 to everything inside the parentheses. So if you do that, that would be negative 10n plus 6. So then I have negative n plus negative 10n would be negative 11n. And then I have 4 plus 6, which would give me 10. So negative 11n plus 10. And then lastly, you'd have to have both of these. So half w minus 3 plus a fourth w plus 3. When you do that, let me just make that a little more clear here. 1/2 w minus 3 when you distribute your half to everything. And 1/4 w plus a fourth times 12 is 3. A fourth of 12 is 3. Now, notice we've got negative 3 plus 3. That's going to give me 0. So I just have to add a half and a fourth. Well, a half is the same thing as 2/4. So 2/4 plus 1/4 is 3/4 w for your final answer. Alrighty. Moving on to the next examples here. This is a good reminder up here. It says to subtract one linear expression from another, add the opposite of each term in the expression. And then it says you can use a vertical or horizontal method. In other words, this is our rules for chop, talking about integers. Whenever you're subtracting, that's the same as adding the opposite. And that's what they want us to do here. And it's you add the opposite of each term in the expression. Okay, so let's kind of go over that here. You can see that I'm subtracting. So what I want to do is to change that subtraction, I'll make it addition, and the next, they're opposite. So 5x plus 6 stays the same. I'm going to change my subtraction to addition, and the next two terms, because each term goes to their opposite. So the opposite of negative x is positive x, and the opposite of adding 6 is subtracting 6. Okay, so let's see what we get when we do that. 5x plus x would give me 6x, and 6 plus negative 6 is 0. That's, you could also think about this as plus negative 6, and 6 plus negative 6 is 0. So that's nothing, so I'm just left with 6x. Right? For the next one here, notice now that I've got a negative 2. It looks like I'm subtracting, or you could also think of this as negative 2. It looks a little confusing here, so let's take this just step by step here. Let's say, for example, you just wanted to distribute the 2 first. So 7y plus 5 doesn't change, and I'm subtracting, right? 2 times 4y would be 8y, and then 2 times 3 would be 6, and I'm subtracting. So minus 2 times 3 is 6, okay? And then let's change our subtraction to addition and the next terms to their opposites. So again, my 7y plus 5 does nothing. That stays the same. It changes to addition and the next terms to their opposites. So negative 8y, and the opposite of subtracting 6 is adding 6. Okay. Now, let's see if I can combine any like terms. I've got 7y plus negative 8y. That would give me negative 1y, which is the same as negative y. And then I also have positive 5 plus positive 6, which is just positive 11. So there you have it. Again, I kind of like to break this into 2 steps. First, I like to distribute my 2 to everything in the parentheses, and then I like to distribute that negative, or in other words, change the subtraction to addition and the next terms in the expression to their opposites. Okay, so don't forget to add the opposite of each term in the expression. It's easy to forget to just change this to its opposite and forget to change that second term there to its opposite. All right, we'll do example 4 together, and then we'll leave off with the Oyos. It says the original price of a cowboy hat is $D. You use a coupon and buy the hat for D minus $2. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat. Okay. Well, let's just think about this. Your earnings are equal to, how do you find how much you earn on something? Well, you take your selling price, so how much you sell it for, and you subtract your purchase price, or how much you bought it for. So let's just write that down. Your selling price minus your purchase price. So if I sold this, let's just stick in a number for $20, and I purchased it for $10, how much did I make? Well, I made $10. Okay. We don't have that situation here. We have a couple of expressions. So let's see if we can figure that out. Do we know the selling price? Well, yeah, it says you decorate the hat and sell it for 2D minus $4. Minus the purchase price, well, we know we bought it for D minus $2. If I were to simplify this, let's see what I arrive at. Okay. All right. let's first change our subtraction to addition and the next two signs to their opposite. So negative d, opposite of subtracting 2 would be adding 2. And then I didn't do anything with this 2d minus 4. Now let's take and add my like terms. So I have 2d plus negative d. Well, 2d plus negative d, well, 2 plus negative 1 is just 1, so 1d. And then I have negative 4 plus 2, which would give me negative 2. So my earnings are d minus 2. That's what you earn. Well, if you paid this for it and you earned this much money, you doubled your money by selling the hat for twice as much as you paid for it. So you doubled your money. Okay, and that might be a little confusing, but remember, this isn't what you're selling it for. This is how much you earned. Right? So if this is how much you earned and this is how much you paid for it, you actually doubled that money. It's actually very similar to this situation. If this is what you bought it for and this is what you earn, notice they look the same. That 10 and 10 look the same. Does it mean that you didn't make any? No, you doubled. So it's a little bit tricky to think about that, but you make that money back. So you can always stick in a number in this situation, and it might make a little bit more sense. So, for example, stick in, maybe let's just stick in a number value like 20. Okay. If let's say you purchase a hat for d minus $2. Okay. Well, stick in that situation this amount. What's 20 minus 2? Well, that's 18. Okay. If you buy the hat for 18, it says you decorate it and sell it for 2d minus 4. So what's 2 times 20? Well, that's 40. What's 40 minus 4? That's 36. So you sell it for $36. Okay. And you bought it for 18. So how much did you make? You make $18. Okay. So if you bought it for 18 and you make 18, you're going to double your money. Okay. All right. Let's take a couple minutes here. Pause the video now to try 5, 6, and 7 on your own. Alrighty, hopefully that these went well. For number 5, you should arrive at 2m minus 15. For number 6, negative 8c minus 25. And number 7, how much do you earn from buying and selling the hat? If you sell it for d plus $2, $4 would be the correct amount. Please let me know if I can help you with any of these. And big takeaways from today would be knowing how to add and subtract linear expressions. So like terms are huge. And then remember those two methods, the vertical method and the horizontal method. All right, that's all I got. I'll stop rambling. See you guys later.